The next set which we have in the lines of a puzzle, or one can say a game scenario, and it's a difficult set to crack over here. Let's look at the set. Baby and Chubby are playing a game which continues in steps. Initially, before the first step, both player rolls an unbiased die exactly once. If they get the same number on the die, then the player keep rolling the die in turns till they get a different number on the die over here. Out of the two different number obtained by the player on the die, the lower number is known as lower limit LL and the higher number is known as the higher limit or a HL. There are plenty of plastic coins available, and in each step only one player picks up the coins. No player picks up the coin in two consecutive steps. The player picks coin as per the following rule. So understand one thing in this particular case, that for example in step number 1, if Baby is picking the coin, in that particular case step number 2 the person Chubby will pick the coin, in step number 3 the person Baby will pick the coin, and so on like this. Now what they are saying is, in the first step the number of coin picked up by the player who got the lower limit or LL on the die in the first step, and he always picks one coin to begin with. Now you need to understand about second step, third step, and so on. The number of coin picked up by the player who got HL on the die in the second step, between LL and HL both included. And suppose the number of coin picked up by the player who got HL on the die in the second step happens to be a. So understand one thing, suppose if I say when they have rolled the die before the first step, suppose the number appear to be, let's say 2 and 4. So I can classify LL as 2 and let's say HL as 4. So in the second step, the person who got this 4 is going to pick a number between the number 2 and 4, and including, one can say, 2 and 4. Extreme points are included. So over here for this example, in step number 2, the guy who got HL can pick a possible a 2 or a 3 or a 4 over here. Now what happens in third step? In the third step, the guy who has rolled the LL is going to pick certain number of coins, and the condition given to us is it's between the number A into LL and A into HL, again both included. So let's take one example where I suppose say the value of A was 3, and we know that the value of, let's say, LL is equals to 2 in the example which I have taken, and the value of HL happens to be equals to 4. So in the third step, if I look at the value of A into LL, which basically mean nothing but 3 into 2 is 6. That's my lower limit in this particular case. And the higher limit happens to be nothing but, one can say, 3 into 4 giving you a 12. So in the third step, the number could be anything from 6 to 12 over here, and this value they are saying is equals to, let's say, some number B. Please note this was only a situation which I have taken to explain the happening in step number 2, step number 3 and subsequent steps. So in the fourth step, what they are saying is the number of coin picked up in the fourth step by the person who got a HL happens to be between B into LL and B into HL. So now B in the previous case, as we have seen, could be anything from 6 to 12, and according the numbers are going to increase and so on. So they have told you over here this process continues in the following steps, and the number of steps picked by each player in each step is equals to between the number LL and HL times the number of coin picked up by the other player in the previous step. As we have seen in the previous one, A, LL and AHL. In the next case, B, LL and BHL, and then maybe you can say C, LL and CHL and so on like this. Now where the game stop? The game stop when the sum of the coin picked up by the two player is exactly equals to 100. If the situation is such that no matter how many coins a player pick up subjected to the rules, the sum of the number of coins picked up by the two players exceed 100, at that particular point nobody picks up the coin and the game is abandoned. And after the game has been abandoned, the player may begin a new game if they want to over here. So they have told you one thing, if the game has to be won, in that particular case, total number of coin picked up by the two player Baby and Chubby need to be exactly equals to 100 over here. Let's look at the questions. So if you look at the two questions over here, again they are situational based question. Again, in the next two also they have given certain conditions. And again, you can see in the last sum also they have given certain condition over here. So this type of set basically can be best solved moment you understand the set. There's no point we can do a start point over here, and we have to move from question to question. Let's try to attack the first question over here. So in the first question they are saying, in a game, after rolling the die, baby got a 2 and chubby got a 3, which basically mean that LL in this particular case happens to be a 2 and the higher limit basically happens to be equals to a 3. That is certain. The game progresses as follows, and what they have given in step number 1, baby pick 1 coin, step number 2, chubby pick 3 coin, step number 3, baby pick 8 coins, step number 4, chubby picks a 18 coin, step number 5, baby picks a 45 coin, and what they are saying is step 5 is the last step played and the game basically is abandoned over here. Because one can understand that after step number 5, the lowest number which can be picked by the chubby in that particular case will be 45 into 2. Because that number has to be nothing but 40 between 45 into LL and 45 into HL, and that number basically will become 90. And if someone does the addition of 1, 3, 8, 18, 45 and 90, the sum is going above 100 and the game basically happens to be abandoned. Let's see what they are saying further. Now they are defining the loser of the game as the player who is the first player, again very important, who is the first player to pick up a number of coins in a particular step, such that no matter how the coins are picked in the succeeding steps, eventually the total number of coins picked up by them basically will exceed the number 100, and hence the game will have to be abandoned. So we need to find out who is the first player who is causing the trouble over here. And what we have to do in this particular case is we have to go by the options. And what I will do is, if I need to find out the first player, I need to find out the earlier step in which the game could have been lost. So what I will do over here is I will start with option number 1 because that is the step number 2. Then I will move to option 2, then option number 3, and then possibly option number 4. So first of all, I will evaluate option number 1, and let's see, because what they are saying is chubby loses because C picked up 3 coins in step number 2 over here. So I assume that these two are correct. Baby picked 1 and chubby picked a 3. And what I will do is, if I want to say option number 1 is not the answer, I have to just create a situation where the total is giving you a sum of 100, where 3 could lead to a win situation as well. So now since we know that LL happens to be a 2, HL happens to be equals to a 3, in this particular case, step number 3, the number which is going to be picked up by the person baby could be between 3 into 2 and 3 into 3, which is 9. So could be anything from, one can say, 6 to 9 over here. So let's say we take the number 8 itself. Now if I assume that this 8 is there, in that particular case this number over here picked up by chubby could be anything between the number 8 into 2 and 8 into 3, which is between the number 16 and 24. Let's say I take the situation of 24 over here. Now if you possibly add these numbers right now, the number of coins picked up in step number 1, 2, 3 and 4, the total over here comes out to be 36 over here, which means if someone pick a 64 coin over here, in that particular case the total is going to be nothing but equals to 100, and one can say we are winning the game. So for that to happen, since I assume that 24 has been picked by chubby over here, so the number of coin which can be picked by baby could range from 24 into 2 and 24 into 3, because LL and HL happens to be 2 and 3. So between the number 48 and 72, which means that this 64 can be easily picked up by baby in step number 5, and as you can see, we are getting into a win situation. And with this, it can be easily said that my answer will not going to be option number 1. Because if it is played in certain number of way, then a win situation can be created by picking 3 coins by chubby in step number 2. So option number 1 cannot be our answer. Let's look at option number 2. Baby loses because C picked up 8 coins step number 3. Just now we have seen that if this are 1, 3 and 8, and this number was 24 and this number was a 64, in that particular case also the sum was coming out to be nothing but the number 100, which means option number 2 is also perfectly fine because that can lead to a win situation and cannot be the answer. Let's look at option number 3, where they say that Chubby loses because C picked up 18 coin in step number 4, which means 1, 3, 8, 18 are perfectly fine. Now understand at this particular moment the total right now is giving you the number 30, which means the number of, let's say, coin still to be picked by the two people should be 70. So if I look at the least possible number and the max possible number of coin which can be picked by, let's say, baby in step number 5 will be nothing but a number between 18 into 2, 18 into LL and 18 into 3, which is between the number 36 and the number 54. And if this is the number 36 over here, and we have just now told that total number of, let's say, coin picked up by the 2 people, 3 people, whatever, should not be more than 70. If this number is 36, then the next number one can say will be minimum 72. So that itself means that in this particular case, this will lead to a lose scenario. Now, if I possibly also have taken the number 54 over here because the max number of coin picked up by baby with this 18 could be a 54. And still, if you look at in this particular case, sum goes to only a 84, and then one can say 16 more coin have to be picked, but no one can pick a 16 coin because the next number should be minimum. One can say 1082 or 162, 54 into 2 and 54 into 3 over here. So what does that mean? Moment the person Chubby has picked up 18 coin, then the person baby can't do anything about it, because this is going to lead to a situation where total number of coin picked up by them is going to go above the number 100, and hence the answer for this particular question will be option number 3, where Chubby is a loser because C picked up 18 coin in step number 4 over here. In the next sum, it is given that in a game, after rolling the die, baby got a 2 and Chubby got a 3, which basically mean again the lower limit happens to be a 2 and the higher limit happens to be a 3. And the game progresses as follows. In step number 1, baby pick 1 coin. In step number 2, Chubby picks 3 coin. In step number 3, baby pick 8 coin, and so on like this. And they are saying that the game has to be completed in exactly 5 steps. How many different combination of the number of coin picked up by Chubby and baby in the 4th and 5th step respectively exist? Now, if the game has to end exactly in 5 steps, in that particular case, one can say the total has to be giving you 100. Now, in this particular case, we look at in step number 1, 2 and 3, total number of coin picked up so far happens to be 1 plus 3 plus 8 giving you a 12, which means if I assume Chubby has picked a number of coin in step number 4 and baby suppose have picked B number of coin in step number 5, then what I want is the sum of A and B should be exactly equals to 100 minus 12 giving you a 88. Let's also figure out what is going to be the range of the values A and B also. Now the value of A, one can say, should be nothing but between 8 into 2, that is the previous number of coin into LL, and the highest number could be for the previous number of coin into HL, so 8 into 2 and 8 into 3. So the value of A, one can say, could be between 16 and a 24. Now, what can I say about the value of B? The value of B, one can say, should be between 2A and the number 3A over here. Now, in this particular case, one can do certain hit and trial because one can say the possible values of A could range from 16 to 24. So we have 9 set of values and we can just see whether these conditions are getting satisfied or not. For example, if I want to check for the number A equals to a 24, in that particular case, if I want A plus B to be equals to a 88, then the value of B should be equals to a 64. Now, I just want to check whether the value of B is in the range of 2A and 3A. So 2A will become 48, 3A will become a 72, and the number 64 happens to be between the range 48 and one can say 72. So this case is perfectly fine. If I take the value of A as 23, in that particular case, the value of B will become equals to a 65. And again, one can see that the value of b, because 2 times of a will be 46, 3 times of a will be equal to a 69, and the number 65 happens to be between the number 46 and 69. This is also perfectly acceptable. If I take the number 22, in that particular case, b will become 66. And now if you look at, the value of 2a becomes 44 and the value of 3a will become equal to 66, and the value of b is exactly between the number 44 and the number 66, including both the extreme point. This case is also perfectly fine. But if I take the value of a as 21 and the value of b as 67 over here, now the value of b should be between 42 and the number 63, but b is beyond the number 3a, and hence this case can be ruled out. So one can now notice that any further case I take, like 20 and let's say 68, since this particular value should be max go up to the number 60, in this particular case can't be taken over here. So we won't get any further case for the value of a as 21, 20, 19 and so on up to 16, and hence one can notice that the values of a and b could be only 3 possible combination, which we have got: 24, 64, 23, 65 and 22 and 66 over here. And hence the required answer for this particular question should be 3 over here. If I look at another intuitive way to find out what is the lower value of a which will satisfy, in that particular case, if I take this particular value as a, then the max I can take it over here as 3a. So one can say, since I want a plus b to be equals to 88, then this will become a plus 3a equals to 88, giving you 4a as 88, or the value of a to be equals to 22. And if 22 will work, we will see that 23, 24 is also going to work, and hence we are going to get only 3 possible cases over here. In the next sum, it is given that in a game, after rolling the die, baby got a 1 and chubby got a 2. So understand, in this particular case, lower limit happens to be a 1, higher limit happens to be equals to a 2. The player who picks up the last set of coin such that the sum of the coin picked up by the 2 players become exactly 100 is declared the winner. And the game goes like this. In step number 1, baby pick 1 coin. In step number 2, chubby pick 2. In step number 3, baby pick 4. Step number 4, chubby picks 8. Step number 5, baby picks 16 coin. This much is given to us so far till step number 1 to 5. Now they are saying a few more steps were played as a part of the game and baby eventually become the winner. So I want the game to end at baby such that total become equals to, one can say, the number 100. How many different ways can the 2 player pick up the coin in subsequent step so that baby will win the game over here? It's a very, very difficult question, given that it's a theta question, and many of you will make a mistake. Many of you will end up marking 10 as the answer, but the answer is not 10 over here. Let's see what is the mistake in someone choosing 10 as the answer. So if you look at over here, if baby has to win, in that particular case, the earliest baby can win could be nothing but in step number 7. Because in step number 6, chubby will pick certain number. In step number 7, again, baby can pick certain number. And since over here LL is equals to 1, HL equals to a 2 over here, then the max value of B in terms of A could be nothing but a 2A. Understand, the total of 1, 2, 4, 8, 16 right now is nothing but 31, which means the value of A plus B should be equals to the remaining 69. Now, what do you think is the values of A which are possible? So understand, the value of A will be nothing but 16 into LL is 1, 16. And 16 into HL happens to be 16 times of 2, which is 32. So the value of A can range from 16 to 32 over here. Now again, we can check for each and every values of A. That could be one of the approach, but we can do some smart work again over here. What about if I look at the largest particular point, which is 32? If A is 32, in that particular case, the value of B will be 37. And I also want to check whether the value of B is between the number A and the number 2A, A into LL and A into HL. So in this particular case, 37 is more than equal to 32 but less than equal to 64 is perfectly fine. And then similarly, if I can take 31, this will become 38. This is also perfectly acceptable. Now what about the last value of A? Similar to what I did in the previous case, I will try to take the scenario where b is equals to 2a. The max value of b can be equals to a 2a. And now one can say a plus b should be equals to a 69. And if I take the scenario of where b is maximum possible, 2a, so a plus 2a will become 3a is equal to 69. So the value of a become equals to a 23. What does that mean? All the cases up to a equals to 23, because that will correspond to b as 46. So A 23 and B 46 is perfectly valid, and the sum will become 69 for A and B, which means the total number of coin picked up by Baby and Chubby will become equals to 100. So all these cases, so if you look at over here, the value of A is going from 23 to 32, and hence this will lead to 10 such cases. And many of us will end up marking 10 as the answer. But please understand one thing over here, that what they have told you is Baby has to win ultimately. So Baby could also win in step number 9 as well. So there could be 4 coins picked up by, let's say, Chubby, and Baby over here. So now what I want is, I want some of the 4 values. If I suppose say these are A, B, C and D, where the value of B will be more than equals to A but less than equals to 2A. The value of C need to be more than equals to B but less than equals to 2B. The value of D should be more than equals to C but less than equals to 2C over here. So now in this particular case also, A plus B plus C plus D must be equals to a 69. And if I take the average of this number over here, which is 69 divided by 4 will give me approximately 17.25. So what I will do is, since the least value of A which is possible is 16, and the subsequent value can be equal to or more than the previous value, so I will first of all distribute 4 16s. And what does that mean? I still have to give 5 more. That 5 can go to D alone, which basically mean I am saying the subsequent step the coin picked are 16, 16, 16 and 21, which is perfectly valid, and in that particular case Baby will be the eventual winner. What about if the extra 5 I am distributing between 2 people, and that should be C and D, such that D is more than equals to C. So I can give 1 here, 4 here, and that means 16, 16, 17 and 20. That is also perfectly acceptable. The 5 I can split between the person C and D as possible 2 and 3, which means 16, 16, 18 and 19 is also perfectly fine. And the number 5, now I will think of distributing between 3 people, let's say B, C and D, and that you can say I can do it like 1, 1 and 3, possibly 16, 17, 17 and one can say a 19 is also perfectly fine. What else I can do in this particular case? Maybe a 1, 2 and a 2. So a 16, 17, 18 and 18 is also perfectly acceptable. And we don't have any further case. So the further scenario could be if I split the number 5 among the 4 numbers, that could be a 1, 1, 1 and a 2, giving you 17, 17, 17 and a 18. So one can notice that we are ultimately getting nothing but another 6 possibility. In that particular case, one can say when Baby wins in the step number 7, we have got 10 possibility. When Baby wins in step number 9, we got another 6 possibility. Now kindly understand, if someone says, can Baby win in the 11th step? And the answer would be possibly a no. Because if I say A plus B plus C plus D plus E plus F equal to 69, in that particular case, the least value for any number in this particular case has to be 16. And that is not possible with the help of 6 number, because the sum has to be minimum 96 or more over here. And hence the required answer for this particular question will be 16 over here. Definitely a very difficult question. Given it's a theta problem, many of you will not be able to attempt it, and those of you who will attempt it may get it right or may get it wrong as well. In the next sum, it is given that in a game, after rolling the die, Baby got a 1 and Chubby got a 2, which basically means that your lower limit is 1 and the higher limit is 2. The player who picks up the last set of coin such that the sum of the coin picked up by the 2 player become exactly equals to 100 is declared the winner of the game. Now, this is a very, very important point in this particular case. The game was finished in the minimum number of steps. What could have been the maximum number of coin picked up in the last step over here. So first of all, see what is the number of step which is going to be required to finish off the game. This is very, very important. So we know that your first step, the number of coin picked has to be, one can say, a 1. That is given to us. And since in this particular case, any particular number, suppose if I say B, should be between the number A and the number 2A, including both the numbers A and 2A. So if I want to finish off the game in the lowest possible number of steps, I should choose as high as possible and not the small number. So the highest I can pick in step number 2 could be a possible 2. Then I can pick a possible 4 in step number 3, because the highest I can pick will be B equals to a 2A, 2 times of the previous coin. In step number 4, I can pick a 8. In step number 5, I can pick a 16. In step number 6, I can possibly pick a 32. The sum right now, as you can see, will become equal to a 63, which means I need to pick another 37, and that is possible if someone basically do it in step number 7. So first thing, the game can be end with this particular scenario in minimum 7 number of steps. So now we have seen that the game has to end in minimum 7 number of steps, and the question says what could have been the maximum number of coin picked up in the last step. So the task over here is Baby will pick the last set of coin to win the game, and I want to find out what is going to be the maximum value over here. Now one need to do a lot of hit and trial, but let's try to do it in a sort of a logical manner. First of all, can I find out the least value? If I want to say this is going to be the least number of coin are being picked in step number 7, which would mean that I should have picked the highest possible coins in the previous steps, 1, 2, up to 6, and that we have seen just now, 1, 2, 4, 8, 16 and 32. I can't pick more than this coins, let's say in the step number 1 up to step number 6 over here. And step number 1 to step number 6, the total come out to be a 63, which means the minimum value of coin which can be picked in step number 7, so the game ends, will be nothing but a 37, with this lower limit as 1 and higher limit basically as 2 over here. So 37 is the minimum that we can easily figure out. But the task was not to find out the least number of coin to be picked in step number 7, but was to find out the max number of coin to be picked in step number 7. And in this particular case, what we will do is we are just going to take a arbit number, and we will see whether that number is possible or not. So if I say in step number 7, the max suppose I take is 50. Now please understand one thing. Suppose if I say in a particular step, if I have picked a number of coin, then in the subsequent step, the number of coin which can be picked will be nothing but between the number A and the number 2A. So it will be max equals to twice of the number, it will be lowest equal to the previous number. Now what about if I want to say in a reverse way, that if this particular number is B, then the lowest value which I can pick in step number 2 should be at least half of that, and one can say the max value for A could be nothing but same as the value of B over here. So if I say that, if I go with this particular logic, please understand, if I say I pick 50 coins over here, then what I want to see is that the sum of the coin from step number 1 to step number 6 should be at least 50. Should be at least 50. Or should be less than equals to 50. Rather, one can say less than equals to 50. Let's see if I make this number. So the lowest value in step number 6 can be half of the number 50 happens to be a 25. So it has to be a 25. Half of 25 happens to be a 12.5, which would mean that this particular number should be minimum 13. It can't be 12, because if I pick a 12, then the subsequent step, the max I can pick is 24. What is half of 13? That will give you 6.5, which would mean that this number need to be minimum 7. Half of 7 is 3.5. So least coin picked up by Baby in step number 3 could be a 4. And then if I look at what is half of the number 4, that will be equals to a 2, and half of 2 happens to be a 1. So let's see what is the total over here, because these numbers are the lowest possible which I can draw in step number 1 to step number 6, provided step number 7 happens to be a 50. So 25 plus 13 becomes, one can say, 38 plus 7 is 45, plus 4 is 49, plus 2 is 51, plus 1 happens to be a 52. Means that this particular sum, when step number 7 the number is 50, then the step 1 to step 6 minimum comes out to be 52 over here. And that means I wanted the max possible sum to be a 50. So we don't have a scope to reduce this. And hence one can say that 50 in step number 7 is not possible. So what I will do, I will work backward. If 50 is not possible, can I work around with, let's say, the number 49? If this number is 49, what I want is the sum of step number 1 up to step number 6 should be maximum, one can say, equals to a 51. If this number is 49, in that particular case, half of 49 happens to be nothing but 24.5. So this number again become minimum 25. And similarly, all this will become 13, then 7, then a 4, then a 2. And again, one can notice that this particular sum is coming out to be minimum for 52. And I wanted less than equals to a 51. What does that mean? 49 as a max value in step number 7 is also not possible. So let's now try with 48. So if you look at the number 48, if I say this is max 48, in that particular case, the sum of step number 1 to step number 6 should be maximum equals to a 52. If this is 48, then the lowest number of coin which I can pick by Chubby in step number 6 will be half of this number 24. Again, half will become nothing but a 12. Half will become nothing but a 6, then a 3, then a 2. So if you look at right now, the sum of 1, 2, 3 is 6, plus 6 is 12, plus 12 becomes a 24, plus 24 becomes a 48. So right now this total basically is giving you a total of 48. And we have the scope of, let's say, making this number increasing by 4. And you can possibly say we can do that by changing certain numbers to some extent over here. So with that particular logic, so we could have made this particular number 4. That's an increase of 1 already, which has happened in the number 48. Then this number, I could possibly make it 8. So another increment of 2 is happening. And we can possibly make this number 13 as well. So with this, the total will become equals to 52. And I have only shown you one such case. But the point is, 48 makes it possible, and hence one can choose to mark 48 as the answer for this particular problem. So please note, the least value over here to end in step number 7 was 37. That was the minimum, and the maximum happened to be equals to a 48. And that is my answer for this particular question. In the next sum, it is given that in a game, after rolling the die, Baby got a 1 and Chubby got a 2. The player who picks up the last set of coins such that the sum of the coin picked up by the two players become exactly equals to 100 is declared the winner of the game. The game was supposed to be finished in exactly 10 steps. First 8 steps of the game are shown below sequentially. Which set of given steps of the game will result in a decisive winner for the game over here? And they've given you set 1, set 2, set 3 and set 4. And this particular sum we will go explore set wise. So first of all, in this particular case, the lower limit happens to be a 1. The higher limit happens to be equals to a 2. So if I say in a particular round, if someone have drawn a A, then the subsequent number, if it is B, that B should lie between the number A and 2A. A into LL and A into HL. In this particular case, if I look at set number 1, the total number of coin picked up so far basically happens to be equals to 1 plus 2 plus 2 plus 3 plus 3 plus 5 plus 8 plus 10 happens to be a 34. Which means you need to pick another 66 coin in, let's say, round number 9 and round number, or step number 9 and step number 10, if I call it as A plus B equals to 66. Now the max value of A in this particular case could be twice of the number 10, which is 20. And the max value for B I can take is 40. Even if you look at, I take the max value of A and B, the sum will become equal to 60 only. And that means that set number 1 will never going to lead to a winner in, let's say, 10 steps. And only set number 1 I can eliminate. Let's look at set number 2. The sum right now, 1 plus 2 plus 2 is 5 plus 4, 9. plus 4 is 13, plus 4 is 17, plus 8 is 25, 25 plus 8 becomes a 33, which means that the total of A plus B need to be equal to a 67. Again, if you take the max value of A to be 16, max value of B to be double of 16 giving you a 32, the max possible sum of A and B can become equals to, one can say, 48 and not a 67. So only set number 2 can also be ruled out. If I check for step number 3, the sum right now 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 4 is 11, 11 plus 6 is 17, 17 plus 6 is 23, 23 plus 11 basically happens to be equals to a 34, which means the value of A plus B need to be equals to a 66. And now if you look at the value of A, which I can take max, is 22, and the value of B I can take is 44. If someone put a 22 plus 44, the sum do become equal to a 66, which means a winner can be, let's say, figure out in 10 steps with the help of set number 3. So we can choose to mark option number 3 as the answer. But one need to be slightly careful because option number 4 says more than one set. So you also want to explore the possibility for set number 4 as well. In set number 4, the sum will become 1 plus 1, 2, 2 plus 2 is 4, plus 2 will give you a 6, plus 3 will give you 9, 9 plus 3 will give you 12, plus 6 will give me a 18, plus 11 gives you 29, which means I want the sum of A and B to be equals to a 71. The max value of A in this case can be a 22, B will be 44, and the max possible sum of A plus B will reach the number 66. It can't go to the number 71, which means set number 4 also will not lead to a winner in step number 10. And hence, the answer should be option number 3. So overall, if you look at this set was slightly difficult one. The last question seems to be slightly on the easier side, but the previous two questions or the last two question number 2, 3, 4, even the first one was not at all straightforward.